Do you think every Toyota automatically lasts 300,000 miles just because it's a Toyota? That's the belief that gets owners into trouble. Not every Toyota reaches that milestone. Some develop serious problems that start so small, so cheap to fix, that most owners walk right past the solution without recognizing it. And the part responsible for one of the most preventable and expensive Toyota failures costs less than a cup of coffee. Today, I'm going to show you exactly what that part is, why it matters more than almost any other component during routine maintenance, and how ignoring it can quietly turn your reliable Toyota into a four-figure repair bill. Let's begin. Why Toyota's reputation for reliability is not automatic. Toyota has earned its reputation through engineering discipline. People do not buy Toyotas because they are exciting or status symbols. They buy them because they want a vehicle that starts every morning without drama, handles daily driving without surprises, and keeps going long after other brands start requiring expensive attention. It is genuinely common to see Camrys, Corollas, and Tacomas with 200,000 miles still running cleanly, still holding oil pressure, still starting on cold mornings without hesitation. That longevity does not happen by accident. Toyota engineers its engines with tight tolerances. Components fit together with precision. That precision reduces internal vibration, lowers mechanical stress, and allows surfaces to wear evenly over hundreds of thousands of miles. When everything functions as designed, the engine stays quiet, efficient, and responsive well beyond what most drivers expect. But here is the side of Toyota reliability that dealerships and oil change shops never mention. Tight tolerances cut both ways. When every component fits precisely, and every system depends on that precision, small maintenance mistakes that would cause no serious harm in a more loosely engineered engine become compounding problems in a Toyota. The engine does not forgive carelessness. It absorbs it quietly, stores it, and presents the bill years later when the repair is no longer simple or cheap. One of the most common places where this silent damage begins is during the one maintenance task almost every Toyota owner performs more than any other, the oil change. The problem hiding inside every oil change. Every time the oil is changed on a Toyota, the drain plug at the bottom of the oil pan is removed and then reinstalled. That happens once every few months for the life of the vehicle. Dozens of times, sometimes over 100 times across the full ownership period. On most Toyotas produced in the last 10 to 15 years, that drain plug is a steel bolt threading into an oil pan made of aluminum. This combination is common in modern automotive engineering because aluminum is lightweight, resistant to corrosion, and dissipates heat efficiently. But aluminum has one critical weakness compared to steel: it is softer. Aluminum threads can handle the correct torque perfectly. They were designed to. What they cannot handle is over-tightening. When a drain bolt is threaded in with excessive force, the aluminum threads do not break cleanly or immediately. They stretch, they deform microscopically. The damage is invisible and silent. There is another detail that makes this worse. On many modern Toyotas, the drain plug head is smaller than on older designs. Toyota changed the geometry as part of general engine packaging improvements. The result is there is less surface area for a socket to grip. When a socket does not seat perfectly, or when someone uses an impact gun instead of a hand torque wrench, the bolt head can begin to round off. The response from most technicians working quickly is to push harder. That force transfers directly into the aluminum threads below. This is how the problem begins. Not dramatically, not with a warning light or a noise, just quietly, over multiple oil changes, with threads that weaken a little more each time. How a routine oil change becomes a serious repair. Most oil changes in the United States happen at busy quick lube shops or dealership service bays where technicians are working fast. That pressure is not always dangerous, but it creates conditions where small mistakes become routine. Drain bolts get tightened too hard. Power tools are used on aluminum threads that need hand torque. The bolt gets cross-threaded slightly because it was not aligned perfectly before the gun started spinning. And the part that causes the most damage of all gets reused instead of replaced. When nothing seems wrong after that oil change, the car drives away. No leak, no warning. Everything appears normal. The damage is internal and invisible, but the aluminum threads have been weakened. At the next oil change, they get a little weaker, and the one after that, weaker still. Then one day, the technician removes the drain bolt, cleans it, goes to reinstall it, and it will not tighten. The bolt spins. It keeps spinning. The threads in the aluminum oil pan are stripped. What began as a routine service call has just become something far more serious. At that point, the options are not cheap. Thread repair inserts like a Timesert or helicoil can sometimes restore the threads if damage is caught early and the surrounding material is still structurally intact. An oversized repair bolt is another option in some cases. But when the damage is severe or the pan material has been compromised, the oil pan itself needs to be replaced. On many Toyota 4-cylinder and V6 engines, oil pan replacement parts and labor can run from $400 to $800 at an independent shop. On some engine configurations where the pan sits deep in the engine bay or requires partial drivetrain removal to access, costs can push past $1,200. All of this from one bolt being tightened wrong repeatedly over years of routine oil changes. The $4 part that prevents it. Here is where the story changes completely, and here is where the solution is almost embarrassingly simple. Every Toyota oil drain plug uses a sealing washer called a crush washer. It is a thin, soft metal ring, typically made from aluminum or copper, that sits between the head of the drain bolt and the sealing surface of the oil pan. When the drain bolt is tightened to the correct torque, that washer deforms slightly. It crushes just enough to conform perfectly to both surfaces and create an oil-tight seal. That is why it is called a crush washer. The deformation is the seal. This part costs between $2 and $4 at any auto parts store. Toyota part number 90430120031 is the most common fitment across Camry, Corolla, RAV4, Tacoma, Tundra, Highlander, and many other platforms. It is a commodity item. Some shops buy them in bulk for pennies each. Here is the problem. When a used crush washer is reinstalled, it has already been deformed once. The metal has already compressed. It cannot deform the same way again on the next tightening. The seal is compromised. When a used crush washer begins to seep oil, the instinct is to tighten the bolt more to stop the leak. That additional force does not fix the washer. It does nothing to improve the seal between two already mated metal surfaces. What it does do is apply excess torque to the aluminum threads in the oil pan. This is one of the most documented causes of stripped Toyota oil pans. Not manufacturing defects. Not bad luck. A $3 washer that gets reused because nobody thought to replace it. The solution is absolute and permanent. Replace the crush washer at every single oil change, without exception, every time. This is not optional maintenance. It is not overcautious. It is the reason Toyota includes torque specifications for the drain bolt and lists crush washer replacement as part of the procedure in their factory service manuals. Toyota knows this matters. The information exists. Most drivers just never see it. Torque specifications exist for a reason, and that reason is your oil pan. The factory specification for the Toyota oil drain plug torque is typically around 27 to 30 foot-pounds, depending on the specific engine and model year. That number was not chosen arbitrarily. It represents the precise force needed to compress a new crush washer into a proper seal without stressing the aluminum threads beyond their design limit. When people tighten drain bolts by feel, they are guessing. On steel components, experienced hands can often guess within an acceptable range. On aluminum threads, that margin for error is much narrower. Too loose, and the washer does not seal correctly, leading to seepage. Too tight, and the threads compress in ways they were never designed to compress. A torque wrench eliminates the guessing. A click-type or digital torque wrench set to the factory specification ensures the bolt is tightened to exactly the right load every time. This is not a tool for professional mechanics only. A basic torque wrench for oil change use costs between $20 and $40 and will pay for itself completely the first time it prevents a stripped oil pan repair. If you change your own oil, adding a torque wrench and a pack of new crush washers to your routine takes less than 2 minutes and costs almost nothing. If you use a shop, ask them directly whether they replace the crush washer at every change and whether they torque the drain plug to specification. The answer will tell you a great deal about how that shop operates. What happens to the oil itself once it is inside the engine? Understanding the drain plug and crush washer protects the oil pan. But protecting the oil pan means nothing if the oil inside it is not doing its job properly. This is where Toyota owners run into a second layer of problems that are just as quiet and just as damaging. Modern Toyota engines face two common oil condition challenges. The first is oil consumption, where small amounts of oil are burned during normal operation, especially as engines accumulate mileage. The second is oil dilution, where unburned fuel from short trips and cold starts mixes into the crankcase oil and thins it. Both problems exist, but oil dilution is the more dangerous one because it happens invisibly, and the engine gives no warning. When fuel dilutes the oil's viscosity drops. Thin oil cannot cushion crankshaft bearings properly. It cannot maintain the film thickness needed to protect cam lobes and timing chain components. It creates wear that accumulates silently over thousands of miles. By the time any symptom appears, the internal wear has already been building for months. Toyota engines that do frequent short trips, commutes under 5 miles, cold weather driving, or stop-and-go urban driving are the most vulnerable. These operating conditions maximize cold start fuel injection, maximize the time the engine spends below full operating temperature, and minimize the heat cycles that would burn off diluted fuel in the crankcase. For drivers in these conditions, shortening the oil change interval below the manufacturer's standard recommendation is not overcautious. It is the correct response to actual driving conditions that the standard interval was not designed to address. Regular oil changes at proper intervals flush diluted oil out of the system and restore the protection the engine depends on. This single habit, more than almost any other maintenance decision, separates Toyota engines that reach 250,000 miles in good condition from Toyota engines that reach 120,000 miles with worn bearings and stretched timing chains. The startup noise that scares Toyota owners and what it actually means. There is a sound that sends Toyota owners to forums at midnight. A brief rattle on cold startup. It lasts 2, maybe 3 seconds, then disappears completely. The engine then runs smooth and quiet as if nothing happened. Owners describe it as a death rattle. They schedule dealer appointments. They lie awake wondering how bad the damage is. In most cases, it is not a death rattle. It is a cold start oil pressure delay, and it is a well-documented characteristic of certain Toyota engines, particularly those with variable valve timing systems and hydraulic timing chain tensioners. Here is what actually happens. When the engine sits overnight, oil slowly drains away from the upper engine components. The timing chain tensioner, which relies on oil pressure to maintain proper chain tension, partially drains. The oil filter, sitting above the pan in many Toyota orientations, may partially drain back toward the crankcase. When you start the engine cold, the oil pump begins building pressure. For a brief moment, the chain tensioner is operating without full hydraulic support. The chain has slightly more slack than it should. That slack produces a rattle. The moment oil pressure reaches the tensioner, the slack disappears and the noise stops. This does not mean damage is guaranteed during that brief window. Repeated cold start rattles over hundreds of thousands of cold starts do contribute to timing chain and tensioner wear over time. But the contributing factors are manageable: oil quality, oil viscosity, and oil change interval. Fresh, full synthetic oil in the correct viscosity flows faster at low temperatures than old or degraded oil. It reaches the tensioner faster. The window of chain slack is shorter. The wear contribution is lower. Switching to thicker oil to muffle the sound is not the answer. Thicker oil flows slower at cold temperatures, which can actually extend the time the tensioner waits for pressure rather than reducing it. The correct answer is clean oil, the right viscosity, changed on schedule. The cooling system behavior that worries Toyota owners unnecessarily. Open the hood of any high-mileage Toyota and check the coolant reservoir. In a significant percentage of cases, the level will be slightly below the full mark. Many owners immediately assume the worst: head gasket, coolant leak, something expensive. Toyota cooling systems are among the most stable and well-engineered in the industry. Over years of service and seasonal temperature swings, small amounts of coolant evaporate from the reservoir. Heat causes expansion and some vapor loss. This is normal behavior in any cooling system that has been in service for multiple years. A slightly low reservoir does not indicate a failing head gasket. A failing head gasket announces itself with white exhaust smoke, a sweet smell from the exhaust, oil that looks like coffee mixed with cream, or an engine that overheats repeatedly. A slightly low reservoir without any of those symptoms is almost always just a reservoir that needs topping up. The correct response is straightforward. Top it up with the correct Toyota Super Long Life coolant, which is pink and should not be mixed with green or orange antifreeze formulations from other manufacturers. Then monitor it over the next few months. If it drops again rapidly, investigate further. If it holds steady at the new level, it was a normal evaporation condition that required a normal response. Why the small things determine the big outcomes. When you step back from all of it, from the drain plug, the crush washer, the torque specification, the oil change interval, the cold start behavior, the coolant level, a pattern emerges. Toyota engines that reach 300,000 miles do not get there because they are magic. They get there because owners understood, either through knowledge or instinct, that small things done correctly compound over time into outcomes that feel extraordinary. A $3 crush washer, replaced at every oil change, protects an aluminum oil pan that costs $1,200 to replace. A torque wrench used consistently protects the same threads from the same damage. Fresh oil on a proper interval protects bearings and timing components that cannot be serviced without opening the engine. Clean coolant at the correct level protects a head gasket that fails when thermal management is compromised. None of these habits is expensive. None of them requires professional tools or mechanical expertise. What they require is understanding why they matter, which most Toyota owners never receive when they buy the car, when they take it to a shop, or when they watch an oil change happen through a waiting room window. The Toyotas that fall apart before 150,000 miles are not unlucky. They are maintained the same way millions of other vehicles are maintained, without the specific knowledge that Toyota's tight tolerance engineering demands. The Toyotas that keep going quietly and reliably into high mileage are the ones where someone knew about the crush washer. Someone used the torque wrench. Someone changed the oil before the monitor said it was urgent. That is the real lesson. Not fear of your engine, not anxiety about every noise, just the understanding that a $4 part, replaced consistently, is worth more to the long-term life of a Toyota engine than almost any other decision made during its entire ownership. If you found this useful, the next video covers one more basic maintenance habit that Toyota owners consistently overlook. It costs almost nothing, and it directly protects components that can cost thousands to replace.